So good afternoon, everybody, and welcome to Panel 3, Innovative Technologies in General Aviation. GA is currently exposed to a very creative and stimulating environment. Hopefully, we can comfort Dominic a little bit with our discussions. We have digitalization, new technologies bringing about great potential as well as new challenges. As you can see there, some metrics are getting very, very common in our discussions. We talk about kilowatt more than before. We talk about energy density. And LOC, the lines of code, is getting more and more importance in very simple general aviation product. Not only because the amount is considerable, but also because they control safety-critical functions. LOC, for those of you who are very familiar with our issues, also means loss of control. And this is a reminder of a priority key risk area for the GA community. The good news is that solutions are at hand. We already heard some of them this morning. And, for example, T4S, technology for safety. How to get there? How to enable T4S? I am confident that our great panelists have good ideas about this. And so I would suggest that we get started immediately. My name is Paolo Salvaterra. I am with the Swiss Federal Office of Civil Aviation. I am in certification and production, and a member of the EASA GA tab. Our panelists are very well known, so my introduction will be short so that we can save time for the conversations later on. I would like to start with Frank Anton, who is the head of e-aircraft at Siemens Corporate Technology. After a long time career at Siemens, by the way, not in aviation, about, I believe, Frank, 10 years ago, the moment that started a new chapter in your career, simply building an electric aircraft. Shortly said, a convinced advocate of electric propulsion systems. And by the way, thanks to Frank's work, typical light general aviation aircraft are flying around with Siemens electric propulsion systems. Welcome to the panel. Then we have Jan-Hendrik Boelens, the Volocopter CTO and co-managing director. After several years in the so-called conventional products area, now he's on the front line of an emerging market, urban air mobility. We are very interested to hear from you, Jan-Hendrik, what this could mean for GA in a larger sense. André Borschberg, the co-founder and executive chairman of H55. Lots has already been said this morning. I think I just would like to rephrase something you mentioned, and electric propulsion will revolutionize aviation, you said. And I believe we are keen to debate with you what this will mean for GA in the next coming years. I would like to introduce then Jean-Luc Charron, the president of the French Aeronautics Federation, the FFA. Jean-Luc is a professor of management and long-term member of the FFA, where he covers several roles. And I would like here to mention Jean-Luc because it was also a topic this morning. You engage yourself in several projects for young pilots and ways to ease their access into the world of aviation. So given your role and particular perspective, you are the ideal sensor, I would say, to get the pulse of the GA community when it comes also to new technologies. We then have Tine Tomazic, general manager of Pipistrel, vertical solution and head of the design organization. Pipistrel and Tine are well-known names in the GA scene. You saw Mr. Boscarolo's presentation a few minutes ago. When it comes to innovative products and key technologies, such as electrical propulsion system, but not only. What I would like to mention here is that probably some of you know the Alpha Electro is flying in Europe and overseas, and particularly in Europe with EASA flight conditions and French and Swiss permit to flight. And this is a test bed for the certification of the first light trainer that we hope will be achieved beginning of next year. So it means Tine is really in the process of getting the vision into the business, and probably can help us understanding what are the issues and challenges he's faced with. And speaking of flight conditions, permit to flight, and the regulatory framework, I would like to introduce Trevor Woods, the EASA Certification Director. As you probably already know, Trevor held several director positions at EASA. I could spend a lot of time talking about the huge range of products you were exposed to, but I would like to mention that Trevor launched his career at British Aerospace in the development of supersonic VSTOL and the UAV concept. So it can definitely be said that being exposed to innovative products and technologies is not something new for you. I think we heard several times today the task of striking the balance between ensuring an adequate level of safety and while enabling the introduction of new technologies. And I think you can definitely help us in understanding what that means. Having introduced our panelists, I would like to give you a couple of information on the format. It's going to be a little bit different from the panels we had earlier today. And to do this, I have the support of John Franklin, the EASA Head of Safety Actions, who is our Slido manager, and will tell us how it's going to work.
So if we go to the next slide, Paolo. Yeah, so rather than just presentations, what we're going to do in this session is split into 3 parts. And at the start of each part, there'll be a question that will support the discussion. And throughout the discussion that Paolo leads, you'll be able to go on Slido and provide answers to the question. So rather than just asking your own questions, you can answer. So in the first case of the first part of the session, the question is, what technologies do you think could be developed and used in GA in the coming years? And I'll then highlight all of the answers to that question you give. We'll put them on the screen, and in addition to the initial discussion, then Paolo and you get the opportunity here to shape the discussion of the panel. You can also then continue to ask other questions, and when we get to the relevant part, then we'll bring the questions on screen as well. So think of it, you've broken your first initial steps with Slido, and now we're moving to your check flight now. So we're making things a little more complicated. Thanks.
So, all right, I suggest we get started with you, Frank and André. I had the pleasure of meeting you in different occasions, and with André to work together on the Solar Impulse. I was always impressed by your firm belief of what these new technologies can do for the future of aviation. Today we're talking about general aviation. So I would like you to introduce what are your visions and what you think is going to happen in the area of general aviation in the next coming years.
Well, in the next coming years, a few years, that is nothing in aviation. I own a couple of aircraft. Sukhoi 29 is the youngest one, 20 years. Belco Junior is the oldest one, 60 years. They are all kind of the same type of engine. Everything is nearly the same. So when you're asking me what is coming in the next couple of years, I am convinced that distributed electric, hybrid electric propulsion will come. That an aircraft for general aviation that is unhearable at the fence of the airport will come. And I'm also convinced that pilot assisting systems will grow more and more. I'm not talking about autonomous, which is, by the way, the wrong word. It's automated flight. I'm not talking about automated flight, but about pilot assistance. I strongly believe that these two things will come. We are working on the first one, the hybrid electric and the distributed propulsion.
Thank you. André, what about your views?
Good afternoon. I would like to start further with the autonomous flight that you didn't want to touch, because I believe that in the long term, I mean, it's difficult to know when this long term will happen, we'll get this autonomous flight, because that's the only way to have enough aircraft in the air. And that's the only way, in fact, to get rid of the weak parts of the chain, which unfortunately will be the human being. Maybe not today, maybe already today, but certainly in the future. So if we see the type of technologies which are coming, it's clear that these technologies will be able to do better what we are doing as pilot. It's difficult to say it as a pilot because I'm flying since 50 years now. And I have the impression, you know, we will be kind of dinosaurs. You know, I wonder if we will have some kind of a Kruger Park for pilots somewhere so we can keep them alive like we do with lions today. We'll see. But it's true, before we get there, the level of automation will increase. You remember the example I showed this morning, that was my second slide, this black fly, it's already there. You already have something which flies electric. The only thing you have to say is that I want to move forward, backwards, left, right, up or down, and the airplane basically is doing everything itself. It will stop if it gets to a zone where it cannot enter, simply. And maybe ask the question, you know, I cannot enter here, what should I do? So this is already today. So to have this, we'll need electric airplanes. We'll need electric propulsion. And it's clear that in the very short term, we'll have this available initially in existing platforms. Challenge, as we heard, is to certify it. And the only way, I think, to certify it is to go step by step. So starting with normal airplanes, like a lot of companies are doing today, make a lot of sense. So in parallel to the certification process, which seems to be difficult today, will make it much easier tomorrow. We know that electric motors are pretty easy to certify. That's the easy part. And it's so simple that it's even difficult to understand why we don't have it today already. We know that the battery is a little bit trickier. But again, in fact, the technology will improve. We'll get to what we call solid-state batteries. So let's say in 5 years, maybe 6, maybe 4, I don't know, but we'll have really safe technology. And in the meantime, we'll find the solution case by case, depending on the technology, to bring this into the air. Maybe at a slow speed, but enough to get confidence. So that's a little bit the way I would describe it.
That sounds pretty exciting. I would like to give a word to Jan-Hendrik, who also prepared a short presentation for us. Again, the same topic for you, and perhaps let's have a look at this new dimension, or it's not really new, it's coming, about sensors, autonomous, whatever the correct terminology could be. Would you like to give us your view of the things? Can you please pull up the presentation?
So before we go into the question on autonomy, I just wanted to show that this is not just the future. The Volocopter is flying today. So we can move ahead with the slides. Because this is not very exciting to look at. Right, so I just wanted to highlight that the Volocopter is flying today. It's been flying since 5 years now. We've performed more than 700 flights with the Volocopter, manned and unmanned. And it's a safe vehicle. We have redundancy built into the DNA of the Volocopter. It's got distributed electric propulsion systems today. It's got a full fly-by-wire system. So safety is really designed in already in the design today. It's simple, so as I said, it's got a full fly-by-wire system. So as you mentioned, the example on the black fly before, also on the Volocopter, the pilot just tells the aircraft where he wants to go, forward, backward, upward, down. It's as simple as that. You don't have a cyclic or anything. So it's very easy to fly, no special training for controlling the vehicle as such. It's also got envelope protection, so you can't really do that much wrong. It's low cost. As we said before, electric propulsion is really leading to a lot lower operating costs, so both in terms of energy and in terms of maintenance. And maybe most important of all is very low emission, not just meaning that we have no carbon dioxide, it's also extremely silent due to the design. And today, well, since 2 years, we're performing manned flights with that system, all with, you see the registration on there, so all with the proper permits from the authorities. So that is the situation we are at right now. But to come back to the point on autonomy, if we really want to open up new markets, and if we really want these low costs to be meaningful, we have to get rid of the pilot out of the cockpit at some point. I like the slide that Dominique was showing before on the car that you would want to buy for your children right now. If we imagine sitting here in 10 years, the car you would want to buy for your children is probably going to be an autonomous car. If you just look where the technology is today in the automotive industry, we can only imagine where it will be in 10 or in 20 years. Just think back 10 years. Nobody was talking about the autonomous car 10 years ago. So where are we 10 years from today? Why should it be any different in aviation? If we don't want to have the same slide there saying we're still flying the Cessna, you're going to see autonomous aircraft at some point in time. I'm not saying it's next year, I'm not saying we're there yet, but obviously we need to prepare for that. And if we want to open up these new kind of applications, also in general aviation, where today you're going to fly because you like flying, but if you just want to hop in an aircraft and actually enjoy that experience, just as in a car, it can be very convenient if you don't have to fly the aircraft all the time. So I think even in aerospace, autonomous aircraft or automated aircraft for that matter, because autonomy is a bit of a tricky word in that domain. They're going to open up new applications and new possibilities there. So I think that's a key technology.
So Jan-Hendrik, Tim Cook said in an interview, autonomous is going to be key, and he sees autonomous as the mother of all AI. You're a great software expert, so how do you see it? Is it really the edge we are going to approach, putting AI in a general aviation product?
I would be very careful to generalize that to AI, to artificial intelligence. I think there are many, many ways, many technologies available to support automation or to support more autonomous functions there. Artificial intelligence, machine learning are parts of that kit maybe. They are technologies, but there are other ways as well. And I think the best way to think of it is just as the slides we've seen before. Aviation didn't start with a 777 or with an A380. It started with a biplane or with a very simple wooden plane. And we've taken about 100 years to come from that to where we are today. So why would it be any different in the case of autonomous flight or automated flight? It will take small steps. We'll start with a very simple solution and start building on that. And who knows where we are 10 years from now.
Thank you. Any comment on these statements?
Well, I think looking at technology, artificial intelligence, and a whole host of things that are coming at the same time. The difference with innovation now is we've got all of these different technologies that are coming to us at the same time. And they're coming from different industries, from non-aviation organizations. And there are people looking at this bucket of toys and saying, well, how can I put these together and what will come out? And as regulators, we're looking at that and seeing all kinds of things. And that's a challenge to be able to regulate whatever is going to come. And it will be too late to wait for that. Whether it's artificial intelligence or additive manufacturing or telecommunications, all these things coming together. And that's a real challenge for us.
Definitely.
But we're ready. We're up for the challenge. And
okay, I'm sure we're going into that. John, do you have anything?
We do, yes. So if we go to slide.
Okay, so we have a first round of questions from you, and let's have a look at What are the hot topics? Okay, very good one. I think it's probably for you. We are talking about the electric, but why not hydrogen?
Okay, the question is this about hydrogen for fuel cell or hydrogen to be burnt in a turbine? Now I take it for fuel cell and say, this is exactly why I have spoken about hybrid electric propulsion. We do not believe that except for niche applications in the near future, which is the next 20 years, a pure battery airplane will have a customer value. Except in niches. There are niches in which it does have a high value, but let's talk about aviation in general, where you want to get from A to B and have like 3.5 hours plus a reserve. Then you will certainly want to have hybrid, which combines at least two energy sources, and that can very well be a piston engine generator or a gas turbine generator plus a battery, but it could also be a fuel cell plus a battery or any other combination of the three. The fuel cell is probably a little bit further on the time scale, but not too much. We are already seeing applications that are even flying with fuel cells. The fuel cell has two problems. It's still a bit heavy, but the bigger problem is it creates a lot of low-value heat, meaning a lot of heat energy at a very low temperature, and it's not easy to get that into the air without increasing the drag of the aircraft. Once you have solved that on the fuel cell side, then the fuel cell will be perfect, and then hydrogen will certainly come.
So it's not why not, it's something that it's in the pipeline. Perhaps we take the second one, non-certified handheld devices like iPad or GPS, so that we will be able to take them from plane to plane and even fly IFR and PBN. So I think this is, we also have to consider this is not simpler, but things that we have to think about. Non-certified handheld devices, what do you think, Trevor?
Well, I think we need to look at the big picture. The complete safety level of the whole environment. And it may be that iPad may run out of battery, you may sit on the screen and crack it, all these things. But how often does that happen compared with a private pilot getting lost, losing his way, being high workload, and these things where maybe it could be a net safety gain? So we shouldn't just look at that in isolation, and we need to look at the complete picture. So why not look at it? And I think it could be a benefit.
Yeah, and Jean-Luc, I believe you are at the forefront of the community. I believe this is something you confirm. This is a real need.
In fact, the panel is about innovation, and I'm not going to talk about technology. If we want to talk about technology and electricity, I can just make the difference between USB plug and normal plug. What I mean is there is a huge difference. As president of the French Federation, we have 42,000 pilots and students. We have 2,400 airplanes, and we use around 500 airports. And air transportation in France is part of a ministry which is called a Ministry of Ecologic Transition. And the main problem is to go from the plane we have now to other solutions. I think that electric power plane is part of the future, especially for the mission, which is essential for us because half of our flying time are for training. But the difficulties is all the stakeholders on the ground. For example, we make, I think, a great job with the DGAC in France, with the EASA and with Pipistrel, because we are working on the Alpha Electro. But the difficulties is, for example, with the fire brigade. They say, what we are going to do with this airplane? air controller in two-cylinder knob. Electric airplane is a very special plane. I don't know why it's very special. Maybe they need a special permission, flight plane. Oh, come on. So we have a lot to explain to all the different stakeholders. And one thing which is very important for the innovation is the instructor. Because electric airplane, the one we can fly right now, for example, Alpha Electro, which is the only plane which is built, on serial production. The mission is training. And so we have to explain to the instructor, this is a mind of state, this is different. We have a lot of things to learn, which are not technological, which are cultural. And this is the main part of my job about the innovation. And that's very difficult. And we, very often today, we have heard of mind state, and this is the main problem. The culture. For example, we have to mitigate the risk of the inflammation, of the explosion of the battery. This is a real risk. But if you take the usual airplane, what about the fuel? We have learned in more than decades, we have learned to mitigate this risk. And it's in the culture. But the new risks are not in the culture. So the people don't know how to mitigate them, so we have to work on that to make the innovation reality in the world of general aviation. That's the main thing about it for us.
Thank you, Jean-Luc. I believe Frank has a comment on this.
Yeah, I have actually two comments on this question. Number one about the real question. Now, when I think about these devices and I fly with them, I experience from time to time that when I need the most, they just freeze or crash. The software crashes or what? Yeah, so that happens. So, could I accept such a non-certified device in an aircraft? The clear answer would be no. Okay, now on a Sunday I fly with my glider and I have this little thing and I maybe have a second one on board and I can not only see all the thermals because I see all the other gliders via the internet because I always have a 4G connection when I'm flying. I can also see all the other aircraft that are not gliders and using the FLAM but all the other systems. And more than once, actually very often, I saw an aircraft on this screen of this small telephone well before I really saw it in the nature. And that gives me the feeling that more often I had more safety by having these devices. So in that case, I would say, hey, the answer is I need them on board. My second comment is I would turn the question a little bit, it's a question about commodity devices, isn't it? And commodity devices have a very fast cycle, innovation cycle. So after 3 years, you get a new iPad, another one, the next one. The same will happen when we go electric. When we go electric, the power electronics and the software, the hardware for the software, will have very fast innovation cycles, and you need not take everyone. But at least after the third, at least after 5 years, you will not get the old chips anymore. So the certifying bodies have to learn how to deal with that. How to deal with the obsolescence problem of electronics in planes that are for good use for 40 years, in which every 5 years you have to probably go for a new type of battery chemistry or for a new type of a chip in your controller. And that means that you really have to consider, we really have to consider whether we would not be willing to certify on the chip level. To certify a multi-core AURIX that is made for these autonomous, I hate the word, for the automated cars, and to think, could we not certify that for aviation? I know that today this is a no-go, but we have to think about the obsolescence problem in electronics. Electronics is commodity.
Yep.
Paolo, maybe a small comment on this question. As we have more and more of these technologies which are useful, extremely useful, simple, but not certified, so not fully tested yet, And with the pace of development that we have in technology, I think we can expect this to be more and more the case. So couldn't we, and maybe that's a question to you from the authorities, could we think about a system or a philosophy which takes this maybe more in account? So on one side, we need the minimum setup, robust, to be able to maintain safety, but maybe you have to interrupt the flight, whatever. And on the other side, you have technologies that you can use, which at the end, 99% of the case will enhance safety. So a better balance, but also the will to integrate this, and not to say, maybe you can use it, but I don't want to know about that.
Well, thanks. I think we are transitioning into the second part of our discussion. We are talking about the gaps. And now you are already throwing into how do we close it. So I would like to keep this comment for later on. Thank you for the questions. By the way, we cannot answer all of them. I would like, but probably we'll come back at the end if we have some time. Tine, you are working on this. There is a 2014 a world premiere with a WhatsApp. And now it evolved into the Alpha Electro, which is a precursor of what will be the first certified airplane in this category. If we play this Mind the Gaps game, where do you see them? Because you are going through the experience now.
Thank you for my turn. Now you're stuck with me for 10 minutes or so. There's many gaps, obviously, and they all seem to confluence into the software part more so than into the hardware part. So I studied electrical engineering because I didn't have the opportunity to study aerospace design near to where we are at. And I believe that innovation could happen because of things moving electrons in aeroplanes and not moving push rods and cables. I was 15 at the time. We did not dream about flying electrically, so my dream was to make better pilots or to get aids for pilots to prevent hurting themselves. If you take a look at history, about the only thing which has not changed since the Wright brothers is the bloody stick and rudder. So is there any particularly good reason why we still have the same interface? It's not a good interface. It's not even intuitive. If you are in a bank and you push left rudder, you go down. So who came up with that? I don't know. But for some reason, the community seems to like it. And for this same reason, people get hurt. So when I started realizing what it would have to be done so that people get assistance, you quickly learn that innovation, or the degree of innovation, has to do with the ability to control things, how well you can control a situation. It's a control problem. It's not inheritably an interface problem, a battery problem, a microchip problem. It's a control problem. And you have to detect, you have to understand, and you have to react. Okay, so there's three functions, always. In 2007, when Pipistrel flew the first electric two-seater, it was a glider. Because gliders don't need reliable powertrains, right? They are safe. They glide, they sink, they land. That's why a glider. For every consequent electric plane we flew, it carried parts it did not need to close the gaps for the next project. What's up in 2014 with Siemens' engine closed the gaps on the battery management system that will now be installed into the T-Seed version coming out early next year. But we are actually in a special time. People say, I cannot certify it because there is no standards. We hear this all the time. I think you can actually certify everything. There isn't a thing you could not certify. It's just expensive and it takes a long time, but that's no excuse. About 10 days ago, standards for integrating electric and hybrid propulsion systems on General Aviation airplane was finally passed after 6 years. It's for the first time that the standard is there and the product is not. Okay, so please do take advantage of this unique situation. So no excuses that it cannot be done. The way the standard came to be was using an approach that I call my little Trojan horse. In 2011, we sat in Daytona Beach at the ASTM get-together when the revitalization of CS23 and Part 23 was to happen. And there was myself raising a hand and saying, hey, how about doing an electric propulsion system standard that includes the engine as well? And everybody was like, yeah, let's do it. That's a cool idea. Engines in CS23, we have CSE, the Americans have FAR 33. Nobody noticed for 3 years. Then came Siemens on board with Jan-Hendrik. People started noticing because all of a sudden they wanted to type certify an engine as part of the aeroplane. Scary shit. The standard was diluted into 2 working groups, the installation and the engine. The installation has passed, the engine will pass early next year. So it can be done using the my little Trojan horse approach. So the Trojan horse continues on the software side in particular. I think Frank is right. Microchips, it's a problem that's been solved in the IT industry. Nobody writes applications for a particular chips. Everything is in a virtual machine. You can change the server overnight and nothing collapses. It still works. A similar approach could be used here. And by the way, innovation is not about inventing things. Inventing means creating from scratch, from something that doesn't exist. Innovating means being clever, using technology that you have seen elsewhere, and making money out of it. This is innovation. And there's plenty of opportunities in how we shift electrons. Software in particular, the methods of certifying that, they are archaic. People will know an approach called DO178. I have a friend here in Austria, Christoph Genster, Robert Kremnitzer knows him well. Together with him, we actually have an internal joke. We say that instead of DO178, we should promote the don't 178. Do versus don't. Just because that method, with that method, you can show very well how hard you tried developing the software, not how good the software actually is. And that's something that aviation has missed. It's creating a huge burden for little effect or an effect that doesn't give a direct and concrete assurance about how good the matters are. And then there is, I will finish quickly, I promise. And then there is matters which are impossible now, and they are not technological. They are linked to how the aviation environment has come to be because of just legacy reasons, I suppose. If all is good, there will be tens of thousands of Volocopters. And I'm sure there will be a problem discovered with them at one point in time because even the smartest people, when they do the best job, they still miss things. And there's still surprises down the road. Wouldn't it be cool if this little problem could be corrected by an overnight software update on tens of thousands of Volocopters at the same time so that they are safe the next day? This is not possible now. Now the software update includes an aircraft going to a service depot where a certified mechanic does the magic and signs off the aeroplane. 13,000 signatures overnight, impossible. So if we want to increase safety, statistics will also start to play a game. And we have heard about economy of scale. We have heard about what drives affordability. So the regulatory side and the organizational side also has to adjust. It's not all in the technology. Technology will happen. Engineers are there to solve problems. There has to be also the administrative, the regulatory support to cater for solutions that engineers could come up with.
Thank you, Tine. And I think we're getting the flair of these gaps. And what about our audience, John? Would you like to show something?
Yeah, we can put the Slido up.
Okay, so let's get started with the first one. Who will oversee the development of the required infrastructure to support the integration of innovative products into busy environments, such as city centers? Perhaps you can have your views on this one?
Well, the question is on oversight. I'm not sure if I'm the right person to comment on the oversight of the infrastructure. Trevor, you want to comment on that?
Well, it depends if we take a traditional approach or an innovative approach, because if we took the world as it is now, we would have heliports on top of buildings. They would be overseen by the national authorities and so on. But if we have one on every building, then that local authority would have to be massive to do that. So that's a good question. First thing that springs to mind is we have approved organisations in our current regulatory framework, and we can give them, we can trust them, we can give them ability to work on behalf of the authority. And so maybe if there are a lot of these kind of facilities, perhaps we need some kind of organisation approval structure where we give them some competence to check and make statements of compliance for those facilities. Could be an idea, but I think we need to be as innovative about that. That's a very good question, as we do about the products.
Yes. And I think we also need to differentiate here. So on the one hand, of course, you have, if we're talking about ground infrastructure, you have the buildings as such. I mean, today it's not impossible to install a helipad on top of a building. So in principle, you have, for the physical infrastructure, you have standards in place. They might be a bit heavy for the new generation of aircraft, but in principle, I think there is a reference for that. If we're looking at air traffic management, if essentially there's going to be a lot more, if there are going to be many more drones, or if there are going to be many more aircraft in the skies, obviously we need the next generation air traffic management system. But again, it could be a logical evolution, I think, of the way air traffic management is handled. Obviously, there needs to be a new technology behind that, but not necessarily a completely new scheme of oversight.
Any other comment from the panelists on this one? If not, I would like to move to the second one, because I believe it's quite significant that we think about the fleet out there with 40-something-year-old airplane. How can innovation help sustain the large number of legacy aircraft powered by certified F-gas piston engines? Want to take it?
Yeah, I take it in an aggressive manner. I say, hopefully not. I would suggest the following. With hybrid distributed electric propulsion, we will be able to build a general aviation aircraft that at the fence of the airport and outside of the airport cannot be heard anymore. 45 decibel or less. If that is possible, and if a manufacturer does it and offers this to the market, then immediately the value of all the old existing planes of the whole installed base will immediately depreciate significantly to, let's say, 20% of its present value. And that will give this manufacturer a big market. And that would be my model. Not thinking about the old, I don't want to name any of these Piper Seminoles or so, and how can we maybe retrofit them. But really think about an aircraft that you cannot hear anymore, doesn't have any enemies around the airport. And today I cannot fly on a Sunday. And if I fly on a Saturday, I have a bad conscience. With an electric plane that you merely don't hear anymore, and Tine's and Ivo's Alpha Electric, if you fly in that, or if you are outside and hear it flying, you don't hear it. And you can even do more. So let's spoil the installed base, and let's generate a new and big market for hybrid electric and distributed and eVTOLs and stuff like that, and get into economy of scale and get a new business.
And all the airplanes are very inefficient. And the question of efficiency, energy efficiency, will be becoming more and more important. And I don't think we'll be able to sustain and keep having inefficient technologies on the ground in the air. We don't have a CO2 tax, but the CO2 tax will have to come. It's clear, if we want to tackle the question of climate change, there will have to be change to be brought into the system. So maybe it's not going to be in 5 years, maybe not in 10, but it will come. So efficiency, and this is what you get with new technologies, efficiency will also be a key parameter on the choice of the solution.
If I can also comment on that, I'd like to draw a parallel to the automotive industry here. The successful electric cars have not been the ones where they took out the combustion engine and they put in an electric motor. The successful electric cars out there have been the ones that have been designed from the ground up as electric cars. I don't think everybody appreciates yet what we can do with distributed electric propulsion. It's no longer about just having one engine, that we just take out the combustion engine, we drop in an electric engine. That is a possible architecture, but we also have distributed electric propulsion that enables completely new architectures. You can have a multitude of motors, I'm not saying engines, of motors on these aircraft, and it allows for completely new flight characteristics, handling. It just changes the whole game. So I think the question of retrofitting, it's really missing some of the most exciting aspects here.
I want to deviate away from the propulsion side because technology, moving electrons, is not just in the propulsion. Legacy fleet, I think it's quite pragmatic, really. So electric aeroplanes will really take off either because of politics, like prohibitions on airports because of noise or emissions or whatever, because they will finally become much cheaper to fly in total ownership cost, total operating cost, including the acquisition, or it's something so cool that you cannot do with anything else. It's a hero moment. On the other hand, the legacy fleet, contrary to expectations, does not become smaller because of technical issues. It becomes smaller because of pilots making mistakes. So there is still low-hanging fruit on the legacy fleet, which is not linked to avgas burning engines or any kind of other magic potato juice drive or silent drives, what we had. But really to how can technology assist the pilot, either by figuring out if the aeroplane is in a healthy condition, like the materials, have they deteriorated, the bonds, the rivets, the fasteners, whatever. They now sell devices where you can check with your phone if the apple is rotten or not without even looking at it. So it's like a magic sensor that tells you if you'll get sick or not. So why not a device like that for the airframe? Wireless air data angle of attack senders with the stick buzzer or a light in the cockpit to shine in your face if you are about to stall spin on final approach. Wireless sensors are scary shit for aviation right now, but they could bring advantages. Why not? So things that move electrons are not necessarily linked to propulsion, but I agree totally that if you couple that with electric propulsion, with the degree of control you have there, you can achieve something that does not exist before and can drive the change in aviation. Just because it's so cool, you cannot do it any other way.
If I can just add to that, some of the technology for safety, if you like, these devices which can add safety, we can also approve those through CS STAN, which enables approval without having to come individually in each case. So if it's something to enable safety, I think that would be a good thing, just while they keep being operated through their aging years of their life.
Frank, you also would like to comment on
that? Implicitly, we have talked also about business numbers. We have talked about installed base, and will it exist? Will it be supported? Will it disappear? And new business with large numbers of these new animals will come up. You have asked for the gaps in general aviation. I think we have not yet discussed one of the biggest gaps in general aviation, and that is the small numbers. Now we are talking about new technologies, be it the control side, be it the propulsion side. Can an aircraft manufacturer who is maybe in the happy situation to sell 500 aircraft per year or 200 aircraft per year, can an aircraft manufacturer plus the manufacturer of the propulsion system or the control system really develop something perfect for this very, very small, these small numbers? Absolutely impossible. So we need economy of scale. And there are only two ways that I can see as of today towards economy of scale. The one is on the eVTOL side. If eVTOL comes, and I'm personally convinced that it will come, then there are potentially hundreds of thousands in the world. So that opens a business for 10,000 or 100,000 new vehicles per year, and really drives everything into economy of scale. And we all know that then you get a payback. That's one possibility. The other possibility is to come up with something like the unhearable aircraft, which has a new customer value and which makes the installed base obsolete. And they all die away immediately, all these aircraft, and there is a big business opportunity. In both cases, however, you have to finance this approach. Somebody has to come and say, I invest my money into that. And here is the second big problem, the second big gap that we have. The fantastic fact that distributed electric propulsion, be it on the eVTOL side or on the aircraft side or on a combination of both, opens the design space so widely. That's the main point. It gives us access to areas in the design space for the aircraft that we have never been able to get into. But it opens the design space so wide that we don't know where it will end up with. We have now 65 manufacturers for eVTOLs, and I'm pretty sure that none of these will be the one which will be the final winner, or maybe one of these will be the final winner. We don't know. The design space is so wide open, and how to explore that, where will we land? Will it be just by chance that one will be successful? Will it be by rules and certification rules that one will be successful? Or will it just that everybody of these will give up and we will end up with not more than a replacement of what we have today?
Yes, and the last comment on this.
Yes, I agree with what Frank said previously about the economy and to get by the number of new aircraft, but also the legacy. I think when a club want to buy a new airplane, very often he sell the old one. So we have to find the transition. You know, you have to work on how we can improve those old piston aircraft. And this is also a link with the other question. I think there is no real opposition or contradiction with automatic things inside the plane. I think people can learn to fly, and if things are going wrong, they can push a button and automatic pilot can take the plane. So there is no contradiction. I think on the contrary, it makes the piloting more safe, and we have to work on that. This is not automatic pilot against human pilot. It's automatic pilot to help the pilot to have the fun to pilot, and if things are going wrong, you can go to autopilot. And that's also what we have to do on the old airplane. We can bring that automatism on old airplane because this is electronic, and with electronic we can do a lot of things, even on old engine, because this is different thing, piloting an engine.
Thank you, Jean-Luc. Thank you, everybody.
Just maybe to comment on that. I think a lot has been said about mindset before. I think here it's similar. We need to think about different new applications, different missions, if you will, for the aircraft here. If we want to get to production numbers, if we want to create scale, we cannot just try to replace one aircraft with another and do the same thing with it. If I look at this here, all of you have one of these, smartphone. It's not a one-to-one replacement for the 1970s phone, which you saw one of the slides previously. It can do different things. It fulfills a different need. It fulfills different requirements. Now, with a new generation of aircraft that is far more silent than before, that is possibly safer than before. I'm not even talking about autonomy yet, but we can think about completely new applications that these aircraft can be used for, and that could drive the demand.
And if you go for new applications, you go also for new customers. Today, and it's linked to the question, the next questions about autonomy, autonomous airplanes, and pilot fun. I think if you go for large production quantities, you go for autonomous flight, or you need the autonomous flight to achieve that. And this is a transportation means, and the customer will be someone like Uber. But it's not going to be an aero club who wants to train pilot to become commercial pilots in large companies. So the world will change there. I mean, the use of the airspace will change. It's already I think, changing today. We already have to share the airspace with drones. And I say that, you know, as a pilot, but it's clear that we will have to share the airspace with this eVTOL. And I have the impression that ultimately they will control the entire airspace, and as I said before, we'll be left at the Kruger Park to enjoy our flying moments.
Thank you, André. I think we're getting to...
And just maybe I wanted to have one comment, sorry to interrupt you.
So we can get to where...
It's funny because I was looking at the autonomous flight in a different way, I mean, because I'm older. So my goal is to have an autonomous airplane when I lose my pilot license because of age reason.
So I'd like
Quick
to...
one.
Yes, I'd like to actually close one of the gaps. Economy of scale, right? Even if we're talking tens of thousands of units, this is peanuts for the electronic industry. This is nothing. This is a production yield of a week, maybe, in a year's worth. There is actually economy of scale in general aviation right now. It is headsets. It is noise-canceling headsets. Because, and I would like to basically approve of Bruno's idea, because the interface is standardized, because the thing is modular. So modularity is something that the regulator could also push towards, and this would cater for affordability automatically as a secondary effect. Okay? So it's in the interfacing that we have to seek for affordability and economy of scale. Otherwise, even tens of thousands don't really matter.
Thank you. I think we are also getting to one of those typical key issues about innovation, the tremendous potential of the new technologies, and at the same time, the need to think about a transition. How do we bring people through this process? Perhaps this can bring us to the final round of comments about how do we close these gaps? Because I believe our audience is also interested not only in knowing what are the gaps, but from you, what ideas are there? I just throw some keywords. I think technology has been mentioned, and software development, I believe, is a topic. Know-how in the community. Do we have enough know-how? Legal framework is probably something that we have to think about. And also would like to mention research. Do we need perhaps help to close these gaps? Who would like to start?
I agree with all of them, and I would throw my own system-level verification. So instead of digging from the details up, take a system, look at it as a system, see how it works, see how it fails, understand how it fails. There's where the research part comes from. And take it as a system. And this will allow you to change parts of it, like the hardware platform, and continue to go in the exact same way.
I think that here there is also a cultural change needed, that aircraft manufacturers maybe are going to have to transition from being composite specialists or metal shop specialists, if you will, into work really becoming more digital and electric companies. Maybe there are skills which in many companies today are not there, which are required to design the next generation of aircraft.
Yeah, if I can add something on the regulatory side, because all these machines are going to be all different shapes, sizes, solutions, everything you can imagine. And so the rules have got to be more objective and either measure performance or be at an objective level. And give an example of the eVTOL special condition that we've just published for consultation. But first, I'll go back to Julian's FCL easy access rules. He said 1,297 pages. I'm not sure if that's accurate or not. We have an e-rules tool as well, which would help with that. So we'll keep our judgment on that. CS27 is 158 pages for small rotorcraft. And our special condition for eVTOL is 26 pages. So the point being that it's written in it aims to be an objective level. Now, I think we've got to learn how to do this, and we're consulting on it, and we'll take comments. It's a similar idea to the CS23 revision 5. But I think we need to write those rules so that the actual objective requirement you can comply with without having detailed means of compliance, because we just end up in a prescriptive set of standards again. So if we go that way, it's a big culture change for the industry and the regulators how to work that kind of process. It's a completely different approach, and this will be a challenge for us all, I think. We can write the rules, but then we've got to use them as well. So one of the gaps, writing objective rules, and we can't write regulations for everything. We don't have the capacity to do that. We have to find another way.
I guess, Paolo, the change is coming from outside. The aviation is so conservative today that the innovation comes from other industries. I mean, drones is one example. The technology that we are bringing to aircraft are coming from other industries. I mean, carbon fibers have been used on boats since a long time, very successfully. And I think we are extremely fortunate to benefit from that. I have the impression we would not talk so much about electric flight today if Tesla would not have existed yet. And this is pulling us. And of course, then the question is, how do we adapt? How fast can we make the change? How quickly can we train people? How fast can we change the process? So this speed of adaptation is limited by human capability. And I guess, as I mentioned this morning, sometimes we have to de-learn. So that's an interesting, that's a fascinating moment. I think that's a fascinating moment for young people who want to join this world, because they can bring a lot, maybe with a fresh mind. So if we can manage, I mean, a good mix between experienced people and new brains, new ideas, that's a way to bridge the gap.
Frank?
Well, we are introducing something new, and that is always connected to making mistakes. Tine mentioned it earlier and said even if you do things absolutely perfect, you will have certain mistakes. You, Tine, spoke about how to then upgrade the software. Let me, even though it is difficult always to say that, let me say in this one case where the mistake was in the aircraft, it may have also a mishap may have been involved with that. And we have had such a mishap. You may know that. We have 6 or 7 different types of aircraft flying with Siemens propulsion systems. There is now one less on the globe, and 2 people died. And even though it is now clear after the investigation that technically everything was running perfect until to the impact, and also the structure was perfect, and that the investigation is probably now turning more towards the human effects, even though this was beating us. It was terrible. It was terrible. Now think about mishaps that are really then connected to the technology. And 1903, it was normal that after 2 years, if a pilot was still alive, he was a lucky guy. Yeah? Then he would die after 3 years. In the 60s, when my father went across the Atlantic, my grandma told me, hopefully everything will go well. Yeah? Flying is a little bit dangerous. Now, today, we are in a situation where aviation is the safest way of transport, and we are introducing a new technology. I don't have an answer to this. There is one answer that I do not want to have, namely that we develop all this technology in Europe, and that the only area where they dare to use it is China, because in China they control the newspapers, and if there is a crash, nobody will hear about it. And this is the only area where they use these technologies, and then after some time they make the experience, and they have the 2nd generation and the 3rd generation, and then it bounces back and they sell us the things. That is the thing that I would not want to see. And now the question is, how can we, with all the effort, knowing that we will still make mistakes, how can we introduce the new technology and get to economy of scale at a time where we do not want to lose and cannot and must not lose a single soul?
Very good question. Let's see, the audience perhaps has additional questions, and we were reminded also to consider the people here in the room. If does anybody have a question you would like to ask with a old-fashioned way with a microphone? So everybody's in slide. Oh, there is one.
Just to build on the last comment on levels of safety, Jyrki in the first panel mentioned the risk hierarchy. And that we accept that different exposures to risk are acceptable according to the assessment and control of risk. If you're moving into an environment where the autonomous vehicle is looked at as a means of transport rather than sports and recreation, should we be looking at the target level of safety that commercial air transport experiences at the moment? And if so, can we achieve that even with a perfectly reliable autonomous vehicle? Can we achieve that operationally in terms of the day-to-day operation of the craft? Or are you going to be looking to general aviation pilots, like many of us in the room, to actually test this technology at their own risk?
I'll start off by referring back to our our special condition for eVTOL, where we have a number of categories in there. Now, it's a starting point for a discussion, but in there we have a category which is envisaged for urban mobility. And so if you think of 1309, we've put the target of 10 to the minus 9 for that category. And then a bit like CS23 revision 5, we've got different levels for different number of occupants in the aircraft for non-urban mobility type of transport. So we're trying to put in there proportionality, but the design of the machine is only one element. Now, if you look at rotorcraft, CS27 and 29 have 10 to the minus 9 targets, but the safety level achieved is nowhere near that. And so we have to look at the whole system, see which are the elements that we need to put mitigations to keep the total level of safety down. And I think we have to be proportional according to the type of operation and the public's perception and what they accept. We had a tragic accident, helicopter accident, within the last week, and we see what the perception is of a helicopter accident within a built-up area near an assembly of people. These are the kind of things we have to consider.
Thank you. Jean-Luc, I was looking at that question the second. All this is future. 10, 20 years down the road, how does this address the GA not generating the amount of pilots required in the next decade? You've been involved in many of these projects, as we said before. Perhaps you can give some suggestions?
Some suggestion. I don't know exactly what kind of suggestion, because on one hand we have more and more supposedly automated aircraft and so on. So maybe we don't need that much pilot. I don't know. We don't know. Anyway, right now, and for the 5 or 7 years just in front of us, we need a lot of pilot. And we don't have enough school. We do not have enough instructor, and I think we have to work also. That's what I say previously, to put more electronic as a way of assistance for the pilot, and I think that will be a way to form better pilot. I mean, on the field of safety, and on a faster way also. So this is not old-fashioned against the new generation. This is a way to mix the electronic and old-fashioned airplane to have this transition to more efficient aircraft or whatever.
Thank you, Jean-Luc.
But it's a funny question in some ways. That's true that on one side we estimate that we need, I don't know, 600, 700,000 new pilots worldwide. When we talk about autonomous flight and getting rid of the pilots, one gets the impression that maybe there will be a huge problem at a certain stage, but that's true. Short term, we need to train more people. And I guess that's a big chance for a lot of new aircraft manufacturers, because I see that there are many companies who developed flight trainers now with new technologies, with the existing technologies, but with new designs or with new technologies. So that's, I think that's a very big plus. And maybe there's also the opportunity to have, for this flight training, part of the fleet electric. Because for aircraft, we have to do circuits and fly an hour, having the chance to recharge the batteries afterwards. That's the application that we talked about before. So I think that's a great opportunity, but the question, of course, will be for me, what will happen to these 700,000 pilots in 20 years? I think autonomous flight will be not autonomous everywhere. The eVTOL will be the first one to get to this point. I don't see a big airliners with 400 or 500 people on board, or 200, being fully autonomous soon. I don't think that a lot of people will agree with that and get used to that. But that's another question.
Okay, I would like to take the last question. Again, apologies, all of them are very interesting, but Frank told me he would like to address these areas like affordable airborne connectivity, data link, weather and traffic.
Yeah, because Anonymous is asking, he or she is missing the connectivity on our panel, so am I. I forgot to speak about it. It's so important. We have among the few general requirements that I have set up for my team when we started developing this. One of these requirements is any of our propulsion systems, be it for application in a ground test system, an Iron Bird, or be it in flight, has to dump its health data into the cloud and it is analyzed there. At the beginning, we said at least after 2 hours, with a delay of 2 flight hours, it has to be in the cloud, because we didn't believe that we will always have connectivity. Now we even go the next step and say we believe that in most of the time we will have connectivity, and whenever we have the connectivity, the data immediately goes into the cloud. We will only sell drivetrains that will have that. And there will be customers who will say, I don't want to fly an aircraft in which it becomes transparent where I am, how fast I fly, whether I fly through what airspace or so. Sorry, then buy from somebody else. If you buy from Siemens, you will get a system in which you have this connectivity. However, we do not intend to make the connectivity a part of the certification of the electric machine, for example. Like saying, the electric machine only needs that and that safety because there is always the additional hearing to the noise of the bearings or so. That we don't want to do. It should be an additional level of safety that enables us to, in the MindSphere, which is the cloud that we are using for that, to analyze that something is going in the wrong direction, that the battery temperature distribution is not the same one as normally, and artificial intelligence is coming into the game. However, there are again different problems to solve. For the electric machine, it is more a symptomatic approach. How is it feeling? Am I hearing a noise? If yes, then maybe after 10 hours or 20 hours there might arise a problem. Similarly, maybe for the batteries, but for the inverter, for the power electronics, it's more a look-ahead matter, because power electronics normally, they do not show any symptoms 10 milliseconds before they fail. So there is a different problem that we have to solve, which goes into the architecture of the power electronics. You have to have an architecture that is robust against losing single power electronic switches and things like that. So yes, connectivity, Internet of Things, the aircraft becomes a part of the Internet of Things.
All right, I think we're ready for the final checks, and I would like to take the opportunity to have another quick round with the panelists. Perhaps a counter-intuitive idea. What important steps should be taken tomorrow at the end of this conference that, in your view, will make a real positive difference for GA in the next coming years? You can start, Jean-Luc.
Without doubt, that will be electric power and more assistance for the pilot with all kind of device, even not certified device. They are already in the plane, and there will be more and more in the plane.
Thank you. Trevor?
Well, we've talked a lot about eVTOL, and I think that this will be fantastic and very exciting, and electric aircraft. But in the shorter term, I think there are lots of opportunities to use technology to improve safety on existing conventional aircraft. And for example, if we look at ground proximity warning systems, when they were introduced, when they were mandated, it completely eliminated CFIT accidents. And I counted up about 10 years before that was introduced, 1,000 people had lost their lives due to CFIT accidents in our European operational database. And after that, there was 0. So this is a real good demonstration where you can target technology for a specific safety risk. So we didn't really talk that much about that opportunity, but I think this is low-hanging fruits that we should take advantage while in parallel we work up for the electric aircraft, which will be much more simple to operate and improve safety even more.
Frank?
We have talked a lot about these moving electrons on the control side and on the propulsion side either. We do not believe that one single company with one single competence can disrupt, because this will disrupt the whole value chain. So when you're asking, what should we do tomorrow? Tomorrow, we should found a joint venture between a GA aircraft manufacturer, an electric company, a combustion engine company, a battery integration company, and a control system company to design and build an unhearable hybrid electric aircraft with mild but significant distributed propulsion and with mild but significant automated control to disrupt general aviation for like 4 persons, 130 knots, 200-meter unpaved runway, 45 decibel at the aircraft fence, and connected in the sense of the Internet of Things, always connected, totally connected. This will disrupt and this will create business.
Sounds like something that many of us would like to fly. Tine?
So I'd like to jumpstart a serious debate on alternative procedures for software qualification, including virtual machines, the concept of apps, basically piggybacking on the fact that the hardware layer may be replaceable, not that software is linked to a particular hardware solution. There needs to be more time invested in understanding how batteries behave. So there's so many different solutions, and I think the community would be benefiting from more knowledge sharing, perhaps through the regulator as well. And the third point is traffic awareness between the general aviation and the big boys, because it will take one mid-air collision between a passenger airliner and a GA aeroplane, and there will be no more EASA GA Safety Conference. So 3 things.
I think there is a lot of positive momentum for electric flight, hybrid electric flight, and eVTOLs in particular at the moment. And I strongly believe we need to capitalize on this momentum to really make it happen now, because, we have the standards in place, partly even before the products are there. We have now certification specifications, CS VTOL, up for commenting. We'll need to keep up this momentum and work together very closely, in my mind, as industry and authorities to move ahead and really make it happen. Because as of today, there is very little that you can buy there out on the market. And that's where we need to go and make sure that you can actually buy these new aircraft.
To develop a complete new solution integrating all these new technologies is a huge task. So I'm very much in favor to some kind of a step-by-step approach, first of all. And second, also developing experience through so-called pilot projects. So I would, very much appreciate if also you as a regulator could favor these so that the industry can not only experiment, but build up on the experience on very focused applications. And I think that's the best way to move this technology forward and to gain enough experience so that we feel comfortable afterwards to implement it at a large scale.
Thank you, André. Thank you, everybody. Well, it was really an interesting journey here, I hope for you as well. And hope we were also able to fulfill the expectations of the audience. And who knows, perhaps trigger a few thoughts that will inspire further ideas and actions. At this time, I would like to thank the audience for your participation. Apologies again, lots of questions that we could not answer, but as it was said this morning, be engaged. We have a GA community webpage where you can post your questions and so we can continue keeping also in this sense the momentum. I would like to thank John, our Slido manager, and the whole team that has been working is still working behind the scenes for making this event possible. For me, it was a real pleasure to be here. I would like to thank my colleagues at EASA for giving me this opportunity and my organization, the Swiss FOCA, for supporting me. Enjoy your evening, and I hope to see you at the social later tonight.